Okay, so let's go ahead and continue with 7.1 with some more examples. So this example is about SATs, which I'm sure we all can relate to. And it states that the length of time taken on an SAT for a group of students is normally distributed and with a mean of 2.5 hours and a standard deviation of 0.25 hours. A sample size of n equals 60 is drawn randomly from a population. Find the probability that the sample mean is between 2 hours and 3 hours. So there's a lot of information here. I want to tell you that the first thing we should notice is that it tells us that it's normally distributed, because we have to know that. And if we don't know that, then we have to check the sample size. So the first thing I would say is given population as normally distributed. So it doesn't really matter what the sample size is at this point, but it is, I mean, if we look at the sample size, it is larger than 30. So, but the fact that it gave it to us, we don't even think about it. The second thing we always want to do is note the distribution. So if we want to note the distribution, that's always discussing the mean with respect to the random variable, which is 2.5, and the standard deviation with respect to the random variable is going to be 0.25 over the square root of 60, because remember the sample size is 60. Okay, and the third part is maybe just writing down what we're looking for and drawing the figure. So if I go over here, I'll see that the mean here is 2.5. And the tick marks, if I wanted to draw them, I did them ahead of time. So 2.4, 2.44, 2.47, and on the right side 2.53, 2.56, and then 2.6. And you can see here that the standard deviation is already really small, and if you divide that by the square root of 60, so if we just did that in the calculator, just to kind of give you an idea of how small this is, so it's 0.032, so you could see that it's 300, so you're like adding and subtracting 300s on each side, so it's pretty small. We're looking like this. Right? So this is the sample mean. So what's the probability that if I took a random sample of 60, that average will be between 2 and 3 hours? Well, let's go ahead and shade that. So now we're looking at in between. So in between 2, way over here, who knows where 3 is, way outside of our area. And if I went ahead and shaded, what do you think this area is? I mean, look, I'm shading the whole thing. What is the area of the whole thing? I know you know it. Yes. The area is 1. So I can only assume that this probability will be pretty close to 100%. Just saying. So let's go ahead and go and put this in. So again, we're going to have the normal CDF. And we have left and right endpoint, so 2, 3, the mean of 2.5, and the standard deviation of 0.25 over the square root of 60. So if I go to the calculator and enter this, I would hit second distribution, normal CDF, and I would change this to 2, enter 3, enter 2.5, enter, and then 0.25 divided by the square root of 60. I would not round this part. Like I wouldn't put 0.03. I would always put the exact fraction with the square root, because the more, if you round too early on, you're going to get error. And so here we always round towards the end. And it says 1. Cannot compute. Must be 1. So we would say that there is, or we, how, no, because one is certain, right? So we could say we are almost, right, certain that a student or a sample of 60 students would take an average of 2 to 3 hours on the SAT. So it's almost certain. I mean, we could see that, and that's why they're able to just give only 3 hours for the exam because they know it's going to be certain that they're going to take between the 2 to 3 hours. And then in mom, you would just put 1. It would recognize it as being almost the whole thing. Okay, going to the last example. In a recent study reported October 29th, 2012, the average age of tablet users is 34 years old. Suppose the standard deviation is 15 years. Take a sample of n equal 100. So the first thing that we want to ask is what are the mean and standard deviation for the sample mean ages of users? So again, they're asking for the distribution. And when we discuss the distribution, we always discuss the average with respect to the random variable. In this case is 34. And the standard deviation with respect to the variable, which is going to be 15 divided by the square root of the sample size 100. Okay, now the next part says, what does the distribution look like? So the distribution looks like, because notice it didn't tell us what type of distribution, but we know that since n equal to 100 is greater than or equal to 30, then we assume the distribution is approximately normal. And this is going to be really important that we always recognize this from now on. Our sample size, normality is going to be here on out. We're always going to talk about this. Not to worry. The formulas, remember, are always on the formula sheet. And if you look on the formula sheet, you'll see all this stuff here and you're good to go. Okay, let's do some problems with this. So it says find the probability that the sample mean age is more than 30 years, the reported mean age tablet users for this particular study. Okay, so then the first thing we want to do is start here and put the actual mean of 34. Again, we always want that 3 criteria. So we know that the distribution is normal since n is greater than or equal to 30. The second part is going to be the distribution, right? Mu sub x bar, which is 34, and sigma sub x bar, which is 15 over square root of 100. Now, because the square root of 100 is 10, 15 divided by 10 is actually a rational number 1.5. So you could put this in there or 1.5. It's only when it's irrational and the decimal goes on forever is when you definitely don't ever want to round. I'm not rounding here. Put it in the calculator. It is exactly 1.5. Okay. And then the third part is to find the probability. So the probability that if we select a sample of 100, that sample mean would be more than 30. Okay, so let's go ahead and label these. Now I did these ahead of time to save time. So they're 29.5, 30, 32.5, 35.5. I'm just adding and subtracting 1.5, right? 37 and 38.5. And so let me go ahead and mark and shade 30, which is here. And I'm looking for that sample mean being larger than 30. Okay, and then we just put that in the calculator as a normal CDF. And our left endpoint is 30. Our right endpoint, notice it goes on forever, so that's positive 1E99, comma the mean, 34, comma 15 over the square root of 100, or you could put 1.5. Just be careful with that. Okay, so let's go ahead and go to the calculator. Let's go to second distribution, normal CDF, and 30 is the lower, upper is 1 second, comma E99. The mean is given to be 34, and the standard deviation is 1.5. Or you could put 15 over square root of 100. It's up to you. Okay, hit enter, and it's going to be 0.9962. So we can see that there's a pretty good chance that that if you took a sample of 100 people, that the sample average would be more than 30 years old of using a tablet. Okay, so let's go ahead and go down to part D, our last example, which I like this one because it's a little different. So the 95th percentile, right? Find the 95th percentile for the sample mean age. And now I'm going to work my way backwards, right? We're going to use those techniques from the previous chapter. And we notice that they're not giving us any sample mean or any age. They're giving us a percentile. So the first thing we want to always know is that it's normal, since n is always greater than or equal to 30. The second part is the sample mean is 34 and the standard deviation is 15, that 15 over square root of 100, or in other words, 1.5. Okay, and the third part now is kind of figuring out what we're doing here. We're trying to find the probability such that x bar, right, the sample mean, has a relationship with some value, and this probability is such that right, it has to do with 95%. Okay, so we do know the 95th percentile. Okay, so here's the average. Where would that 95th percentile mean, and what does the 95th percentile mean just in general? Well, remember, here's the 0 to 100, here's 50. The 95th percentile is right here near 100, meaning we have this separates the top 5% and the bottom 95%. This means that if I went ahead and labeled the x-axis as usual, and marked where this was, which I don't know, I just know that the 95th percentile is somewhere over here, right? And if this is the barrier between the upper 5% and the lower 95%, you know, there's a couple of ways I could do this. I could either use it as a lower bound of 95% or then an upper percentage of 5%. So it's really up to you how you go. I just stick with the 95%, and notice 95% would be the values less than it. So what I want to do is find C, right? I want to find C such that what does the sample mean have to be such that it's going to be the barrier of the 95 percentile? So recall back in the previous chapter where we used, in this case, when we had to work our way backwards, we used invnorm. And we used invnorm to find these missing values. And really what it was is just the area that you're looking at, right? Standard mean and standard deviation. And then we're going to do left, right? Area to the left. And we just put that in the calculator and it's going to give us the age. And so we go back to second distribution, invnorm, which is number 3. And the area to the left was 95%. And then 34 for the mean and 1.5 for the standard deviation. And that 95% was the area to the left. And notice this is going to give us the year. So this gives us 36.5. So this is the answer, right? 36.5 years old. So in this case, it's actually here, right? In between the first and second standard deviation away from the mean. Okay, so this means that 95% of sample means are less than 36.5 years, and 5% of sample means are more than 36.5 years. Sorry for the sloppiness. Don't judge me.